Now, in this video, we are going to discuss moment to change trim by 1 centimeter. Now, we are going to start with the paragraphs first before we proceed with the boring calculations. Moment to change trim by 1 centimeter is the moment required at that particular draft to change the trim of the vessel by 1 centimeter. In ship stability, moment means weight per unit distance. MCTC varies directly proportional to the density of the water. So to some extent, okay, moment to change trim is directly connected or intertwined with the density of the water. Less dense water needs less moment to change her trim by 1 centimeter. And as an inverse of that one, and in high dense water requires more moment to change the trim of the ship. The change of trim at any particular draft depends on the density of the ship. Floats. Loading manual provides the MCTC value for saltwater density. Thus, if the ship floats in water density other than salt water, it is necessary to correct the MCTC value obtained from the loading manual corresponding to the density of the water the ship floats to achieve a correct change of trim. The formula for the finding corrected MCTC as follows. Now, why do we need to correct the values, okay, or our formulas? Is because, again, the loading manual provides the MCTC value in saltwater density. So if you are on board the ship, make sure that you have read your hydrostatic manual. There is a paragraph or a small statement in your hydrostatic manual or loading manual that will say, oh, the values given here are for saltwater density. What is saltwater density? 1.025 tons per cubic meter. Okay? This is the formula for it, and we will derive new MCTC over new density equal to saltwater MCTC divided by saltwater density. So as we derive this, okay, new MCTC is equal to saltwater MCTC times or multiplied by new density divided by saltwater density. Saltwater MCTC refers to the MCTC obtained from the hydrostatic table, and saltwater density always corresponds to saltwater density. Okay, or inulit lang. New density refers to the water density the ship floats at that time. Okay, the application of this. Corrected MCTC to be used in change of trim. When the vessel is loading at a certain port, okay, on a specific port, we're at the density of water, okay, where the density of water is less than salt water in the final trimming of the vessel to achieve a desired trim. On completion, the MCTC corresponding to water density shall be used in calculating the required change of trim of the vessel. A maximum loadable quantity of cargo can only be attained by finishing the ship on an even keel. The ship needs to be on even keel. The use of MCTC is determining the change of trim of the ship when weights are loaded or probably discharged or shifted within the ship. Accuracy of the change of trim depends solely on the accuracy ng MCTC value and distance of weights loaded or discharged from the center of flotation. And for shifting, the longitudinal distance, the weight is the shift from its original position to new location expressed in meters. So this is the formula down below. Change of trim, weight times distance divided by corrected MCTC. Now, let's proceed with the calculations, and I'm going to solve this in real time. Okay, I have my calculator here. Okay, exercise number 7. It's exercise number 7 because this is a continuation from my other trim and stability videos. Finding the new MCTC and change of trim. MV Egeo 1 is loading cargo in port where the density of water is 1.015 tons per cubic meter also. It's less than saltwater density. Okay? Draft check at near completion of loading. Draft readings are forward 13.22 and aft 13.62 meters. Find the new MCTC corresponding to density of water if a weight of 300 tons is shifted from number 6 cargo hold to cargo hold number 2. Okay, so mag-shift tayo ng kargada. Okay, so this is the solution. I'm going to solve this in real time. Okay, find the initial TMD or true mean draft first. Okay, calculate the mean draft 4.5. Okay, draft perpendicular. Okay, plus forward perpendicular plus yung aft 13.62. And then we divide the answer by 2. Okay, the answer will be is 13.42. And never forget on putting the units. Okay, always show in your computation what unit is. Is this meters, tons, centimeter? Always put the unit, meters. Now, letter B, calculate the correction for true mean draft. Okay, we have to correct them because again, this is the mean draft for, at this particular situation. So we have to correct it. Okay, correction is equals to trim times LCF divided by LBP. Okay, now I will show here in the screen the proper tables. Okay, correction, what is our trim? Now, trim is the definition of, okay, what is the definition of trim? Trim is the difference between forward and aft drafts. Okay, so 13.62 minus, okay, let's compute 13.62 minus 13.22. So the trim is 0.40. Okay, that I use the MD or the mean draft on your hydrostatic particulars. Okay, the LCF for mean draft 13.42 is, LCF is 3.62 divided by the LBP for MV Ageo 1, this is only an example, is 220. Okay, length between perpendiculars. So right now, okay, we are going to solve 0.4 multiplied by 3.62, okay, divided by 220. So the correction for this is 0.006. Okay, some people want to make it 0.07, 0.006. Okay, in this example, I would use 0.006. Now, for letter C, to find the true mean draft, we just have to add A and B. Okay, so 13.42, okay, 13.42 plus 0.006, the answer will be 13.43. So the true mean draft, okay, at this example is TMD equals 13.43 meters. Meters, okay. Now, obtain the corresponding MCTC at true mean draft in hydrostatic table. Now, in my hydrostatic table, okay, you have to understand that you have to find the average. Okay, there's no such thing as 13.43 on the hydrostatic tables. It's always even numbers here. When the ship floats, okay, number 3, find the corresponding MCTC for density of the water, 1.015. Okay, when the ship floats, okay, adjust natin. Okay, let's adjust a little bit. And there we go. There we go. Okay. When the ship floats in water density other than salt water, okay, find the new MCTC corresponding to the new, okay, to the new density by formula. Okay, new MCTC, okay, this was our example way back. Okay, new MCTC is equal to saltwater MCTC multiplied by new density over saltwater density. So again, this is the saltwater MCTC. Okay, 1056.59, our answer earlier, multiplied by 1.015 divided by 1.025. The answer is 1.046.28 tons per meter. The new MCTC shall be used for calculating the change of trim of vessel floating in that water density. This will be discussed further in the next videos. How the change of trim is obtained and applied in your forward and aft drafts. Okay, so we'll take it slow. Number 4, find the distance to shift from the weight of origin to a new position. Check your trimming table. Now, I'm going to show here the trimming table. Distance is equal, so this is the formula, LCG of aft hold subtracted with LCG of forward hold. 44.17 minus negative 56.25 equal to negative 100.42. Okay, equal to 100.42. Now, negative plus negative, okay, is positive. Okay, we plus this, we add this together. And bakit po negative? Why did we use a negative sign? The reason why we use the negative sign is because 56 is higher than 44. Now, number 5, find the change of trim. Calculate the change of trim effect by shifting weight forward. Now, if you remember correctly, okay, we are going to shift 300 tons of cargo from number 6 hold to cargo hold number 2. Okay, so we go down again. Calculate the change of trim effect by shifting weight forward. The change of trim, weight times distance over new MCTC, the formula from earlier. Okay, so 300 times negative 100.42 divided by 1.046. That's the new MCTC. Okay, and the answer is negative 28.8 centimeters trim by the head. Why is it trim by the head? Okay, negative 28.8 trim by the head. Okay, it says here, I put here, okay, I put here, number 1, if we shift forward, produces a negative trimming moment. We started from number 6 cargo hold, then we shifted to number 2 cargo hold. But if we shifted astern, okay, shifting astern produces a positive trimming moment. If we shifted from number 2 cargo hold to number 6 cargo hold, the answer would be a positive trimming moment. The answer would be positive 28.8. So again, this is only just a quick example. Okay, in the next videos, we would explain further how can this be applied on board your calculations on board the ship. Okay, so again, I'm ending my video here. Hope you guys learned something new. Be happy, be healthy, and most importantly, to God be all the glory. Keep safe, take good care.